everyone, welcome back to my YouTube channel, She Coding. So today we are going to continue the Part B programs using R programming software. Okay, so the first program is write a R program to calculate the central tendency, that is mean, median and mode. Before starting with the program, let us know what is central tendency. So central tendency is a statistical concept. Okay, iದೇನು define ಮಾಡುತ್ತೆ or ಇದೇನು describe ಮಾಡುತ್ತೆ ಅಂದ್ರೆ ಒಂದು average or the middle values of the particular data set. It's a way to summarize and make us understand the typical values. So simple ಆಗಿ ಹೇಳಬೇಕು ಅಂದ್ರೆ it helps in simplifying the complex data and understand the core characteristics. So we have three main measures idರಲ್ಲಿ mean, median ಮತ್ತೆ mode. So mean will give you the average of the data set, median will give you the middle value of data set, and mode will give you the most frequently used values or most frequently appeared values in the data set. So without wasting our time, let's get started with the program. This is my data set that is in the form of vector. ಈ ಲೈನಲ್ಲಿ ನಾನು duplicates ನ remove ಮಾಡ್ತಾ ಇದ್ದೀನಿ using the unique function. So unique of parameter I've used is the data. So ಈ data set ಅಲ್ಲಿ ಇರುವಂತಹ duplicates ನ I will be removing and storing it in the unique value variable. In this line, ಟ್ಯಾಬ್ಲೆಟ್ ಫಂಕ್ಷನ್ ಮತ್ತು ಮ್ಯಾಚ್ ಫಂಕ್ಷನ್ ನಾನು ಯೂಸ್ ಮಾಡಿದ್ದೀನಿ. ಈ ಮ್ಯಾಚ್ ಫಂಕ್ಷನ್ ಏನು ಮಾಡುತ್ತೆ ಅಂದರೆ ಡೇಟಾ ಎಲಿಮೆಂಟ್ಸ್ ಅಲ್ಲಿರುವಂತಹ ಪೊಸಿಷನ್ ಏನಿದೆ ಅದನ್ನ ಫೈಂಡ್ ಔಟ್ ಮಾಡುತ್ತೆ. ಸೊ ಅದಾದಮೇಲೆ ಈ ಟ್ಯಾಬ್ಲೆಟ್ ಏನು ಮಾಡುತ್ತೆ, ಇಲ್ಲಿ ಫೈಂಡ್ ಔಟ್ ಆಗಿರುವಂತಹ ಪೊಸಿಷನ್ನ ದಿಸ್ ವಿಲ್ ಕೌಂಟ್ ದ ಅಕರೆನ್ಸ್ ಆಫ್ ದ್ಯಾಟ್ ಪೊಸಿಷನ್. ಆ ಪೊಸಿಷನಲ್ಲಿ ಎಷ್ಟು ಎಲಿಮೆಂಟ್ಸ್ ರಿಪೀಟ್ ಆಗಿದೆ ಅನ್ನೋದನ್ನ ಇದು ಕೌಂಟ್ ಮಾಡುತ್ತೆ. ಈ ಫಂಕ್ಷನ್ ರಿಸಲ್ಟ್ನ ನಾವು ಫ್ರೀಕ್ವೆನ್ಸಿಯಲ್ಲಿ ಸ್ಟೋರ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. Which dot maximum frequency, this will find the index of maximum frequency. Maximum frequency ಏನಿರುತ್ತೆ ಅದರದ್ದು ಇಂಡೆಕ್ಸ್ ವ್ಯಾಲ್ಯೂನ ಇದು ಫೈಂಡ್ ಔಟ್ ಮಾಡುತ್ತೆ. ಆ್ಯಂಡ್ ಯುನೀಕ್ ವ್ಯಾಲ್ಯೂ ಏನು ಮಾಡುತ್ತೆ, ಅದ್ರ ಕರೆಕ್ಟ್ ಆಗಿ ಕರೆಸ್ಪಾಂಡಿಂಗ್ ಇಂಡೆಕ್ಸ್ನ ಇದು ರಿಟ್ರೀವ್ ಮಾಡ್ಕೊಳ್ಳುತ್ತೆ ಫ್ರಮ್ ದಿಸ್ ಯುನೀಕ್ ಡೇಟಾ. ಸೊ ಈ ರಿಸಲ್ಟ್ ಏನಿದೆ ಮೋಡ್ ವ್ಯಾಲ್ಯೂ ಅಲ್ಲಿ ಸ್ಟೋರ್ ಆಗಿದೆ. ಓಕೆ, ಸೊ ದ ಫಸ್ಟ್ ಥಿಂಗ್ ಇಸ್ ಮೀನ್. ಮೀನ್ ಇಸ್ 5.153846. ನೆಕ್ಸ್ಟ್ ಇಸ್ ಮೀಡಿಯನ್. Median is 5. Mode is also 5. This is the first program. We'll move to the second one. In the second program, we are supposed to calculate the standard deviation and variance for discrete and continuous series. So before getting into the program, let us know what is discrete and continuous series. Discrete series andre it will have the counting or countable values like whole number 1, 2, 3 ee tara discrete values irutte. But when it comes to continuous, this will have the measurable or what we can say decimal values. Okay, decimal values na continuous series store ಮಾಡ್ಕೊಂಡಿರುತ್ತೆ. And the simple difference between both are discrete is a countable and continuous is a measurable. So let us go to the program now. This is my data set, okay, which has few values in it, and then I will be printing the variance first. So my variance is using var function. I will be printing the variance. In the same way, I will be printing the standard deviation using SD function. So my standard deviation is 3.06006. Okay, this is my variance and the standard deviation. Class interval is equal to vector of from, it might be from 0, starting from 0 to 10. So this is my class interval. This will define the interval of for the continuous series. Adadmele I'll be finding the frequency. Suppose like 5, 15, 10, which will represent the number of observation within each class. The next will be the midpoint. This will calculate the midpoint of each interval, each class interval. This is a crucial for continuous data. Okay, iದೇನು provide ಮಾಡುತ್ತೆ ಅಂದ್ರೆ this will be providing the representative values for the intervals. Okay, and then n will hold the sum of frequencies. And now the mean value. So midpoint na respective frequencies alli weigh ಮಾಡ್ಕೊಂಡು ನಾವು mean value na find out ಮಾಡ್ತೀವಿ. Okay, so there is a formula to find out it. The sum of midpoint into frequency. Okay, so midpoint into frequency, that is divided by n. This is the formula to find the mean value. So the variance formula is sum of frequency into midpoint minus mean value to the power of 2 divided by n minus 1. This formula accounts for the spread of data around the mean. Next is the standard deviation. Will hold the square root of variance. So ಇಲ್ಲಿ ನಾವು ಮಿಡ್ ಪಾಯಿಂಟ್ ಏನಕ್ಕೆ ಯೂಸ್ ಮಾಡ್ತಿದೀವಿ ಅಂದ್ರೆ ಅದೊಂದು ರೇಂಜ್ ನ ಸಮರೈಸ್ ಮಾಡುತ್ತೆ, ಲೈಕ್ ವೇರಿಯನ್ಸ್ ಅಥವಾ ಮೀನ್ ನ ಪಾಸಿಬಲ್ ಕ್ಯಾಲ್ಕುಲೇಷನ್ಸ್ ನ ಇದು ಮಿಡ್ ಪಾಯಿಂಟ್ ಮಾಡುತ್ತೆ. ವೆನ್ ಇಟ್ ಕಮ್ಸ್ ಟು n, so n will represent the total number of observation. Normalizes the sum to provide the average. Okay. So after this, we will be printing the variance and the standard deviation using continuous series or data. This is about the second program. Now we'll move to the third one. So the third program is we need to write a R program to calculate coefficient of variance for discrete and continuous series. So before we had to find the variance and the standard deviation for discrete and continuous. Here we need to find the coefficient of variance for discrete and continuous series. So in order to do that, we should have the data. So I'll take the same data which I've used for the previous. I will be finding the mean value using mean function for the data I mentioned above. Mean value admele next is the standard deviation. So standard deviation ke SD of data, as I said before. CV is the next variable. This means the coefficient of variance and simple CV anta variable haktini. So the formula is to find as STD standard deviation divided by mean value into 100. Okay, this is the formula that will give the value in percentage. Okay, so next we will be printing. Okay, the next will be the continuous series. In the continuous series, as like before, we will be giving the class interval. So same 3 intervals, and then the frequency is also same, the midpoint is also same, n is also same, mean value is also same, standard deviation variance is also same. I will be using the CV formula. This is the continuous coefficient of variance, that is CV. This is also in the percentage format. This is 41.93591%, approximately 42. So this way we can find out or calculate the coefficient variance for discrete and continuous series. Okay. Next, we'll move on to the fourth program, that is write a R program to calculate simple linear algebra operations. So before that, let us know what is simple linear algebra operations. As you all know, it is a branch of mathematics that deals with vectors, matrices, linear equations. Okay, so vectors are nothing but the directions, addition, scalar, multiplications, and the matrices like rows, columns, addition, multiplication, inverse, etc. So linear equation is nothing but y is equal to mx plus b. So anything, if you need to find the slope, intercept form, and line, anything, we need to use this formula. And solving for variables. In simple linear algebra operations, it consists of combining the vectors, multiplying vectors, and finding the matrix reverse. So these are the operations will be performed in using linear algebra. It is very simple, just you need to concentrate on the syntax that we are using here. So we'll create a matrix first. So my first matrix is A, matrix of 1, 2, 3, 4, where I have the n row, that is number of rows, 2, and I will be arranging my matrix in the form of row and not in the column. So by row will be true. So by row means the elements will be arranged by row, not by column. Okay, so I'll create one more vector, that is B. Okay, 2 vectors is created. Now we just need to perform the addition, subtraction, multiplication operations on these 2 vectors. That's it. So now I will be using the print function in order to add 2 matrices. Okay, so I have got this. Now I will subtract 2 matrices by using the same function, that is print. Okay, then I will multiply the matrix using same function. So in order to print the matrix product, I will be using the percentage symbol. Okay, so this will multiplies the matrix in our programming. And then to print the transpose P of A, transpose of matrix A, and then print the determinant, that using that I'll print the determinant of matrix A. Now I'll print the inverse. In order to print the inverse, I will be using solve matrix A function, and this will print the inverse of matrix A. So simple program that is used to calculate the simple linear algebra operations. So addition, subtraction, multiplication, transpose, determinant, and inverse. So as I said you, in this program you just have to remember the syntax to create matrix and the formulas to compute the matrices. So we'll move to the next program. Next program is the fifth program, that is we need to write a R program to calculate arithmetic mean for grouped and ungrouped data. It is nothing but we need to calculate the mean for grouped and ungrouped data. First create the vector. Now I will be using mean val variable data, and then I'll be printing. So this is the arithmetic mean for ungrouped data, that is 20. For grouped data, my formula will be different. I will be giving the values, okay, then frequencies will be mentioned, and this is for the grouped data. So I'll give mean group variable, okay. So sum of values into frequencies divided by sum of frequencies. Now I will be printing 36.6667. So this is for grouped data. We'll move to the next program. So my next program is the sixth program, to write a R program to calculate cumulative sums and products, minima and maxima. Okay. So in order to calculate the cumulative sums, products or minimum and maximum, we need to create a vector first. Now I'll just simply print cumulative sum, cum sum of n. Okay, this will be my printing statement. In order to print the sum, I will be using the function called cum sum. Okay, so the function is 1, 3, 6, 10, 15. So I have not told you how this works. So this will work by adding these two first. The sum of these two will be then added with the next element. Suppose 1 plus 2 is 3, 3 plus 3 will be 6. So it is written here. Okay, again 3 plus 4 is 10, 10 plus 5 is 15. So sum of two numbers is then added with its next number, changed to product of n. So this also works similar to the sum. Now let us find the minimum and maximum. So to find the minimum, min of n, that's it. Then max of n. This is how we find the cumulative sum, product, minimum and maximum. Just we need to use the cum sum for sum, cum prod for product, and minimum min function and maximum is max function. That's it. Next we'll move to the next program. Our next program is write a R program to calculate frequency distribution for discrete and continuous series. So we have calculated the standard deviation, variance for discrete and continuous. We have calculated coefficient of variance. Now we are supposed to calculate the frequency distribution for discrete and continuous series. So here let us create a vector called data. So next I will be calculating the frequency. So this will calculate the frequency of each unique value in vector data and stores the result in the table called frequencies. Next, print the frequency. It is in the form of table. Okay. Next, one more vector I'll be creating. This will be my vector for continuous data. Next is the break. Break will create a sequence of breakpoints. So I will be using sequence method, in which I will have the minimum of data, maximum of data, and the value must be increased or incremented by 2. This simply creates a sequence of breakpoints for the frequency table. It starts from the minimum of data and ends at maximum of data, incrementing by 2. Frequency cut. So here what I'm doing is I'm categorizing the values in data based on the defined breaks and storing in the frequency in new variable. Okay, ಹೇಗೆ break ಆಗಿದೆ ಅನ್ನೋದ್ರ basis ಮೇಲೆ ನಾನು ಇಲ್ಲಿ categorize ಮಾಡ್ತಾ ಇದ್ದೀನಿ. I'm using cut function. Next, I'll be printing the frequency in the form of table. So it is showing us that how many data points fall into each group. So the frequency table is showing us how many data points will fall into each category. Okay. So we'll move to the next code. Write a R program to calculate simple linear regression. Before getting into the program, let us know what is this linear regression or simple linear regression. So regression is a statistical method that will establish a relationship between the two or more variables. So in other words, we can say it as it will predict the continuous outcomes of the variables based on one or more predicator. The program which we are executing is based on the cars. So here we will be using the simple linear regression. That means so only one dependent variable. Let us move to the program now. Data of empty cars. So empty cars is a package that is inside the R programming. Okay, so the next is model. Inside model we are using LM of MPG, that is miles per gallon. Okay, as we are taking the data of empty cars, that is cars, so we are calculating the mileage per gallon. Okay, negation of weight is equal to empty cars. Next, we will be printing the summary of this model. So summary will give you the mean, median, significance, coefficients, and etc. as a summary. Okay. So this is the output for your estimated MTCAS. We are demonstrating the simple linear regression in this way. So that's it for this video, guys. Hope you found this video helpful. Kindly do like, share, and subscribe to my channel, and do support me. Until next time, see you. Bye bye. Take care.